Hi everyone, welcome back. So GFG problem of the day today is shortest path in undirected graph. We are given an undirected graph having unit weight of the edges. We have to find the shortest path from source to all the vertex, and if it is unreachable to reach any vertex, then we have to return -1 for that vertex. So this is a simple algorithm based question, graph based question. So first of all, we see two things, that it is an undirected graph, and second we see is unit weight of edges, means each edge has a unit length weight. So these two conditions are suitable for us to apply BFS. BFS can work as a single source shortest path algorithm in case of these two conditions. That means the graph should be undirected and each edge must have a unit weight. So we can now simply apply the BFS, level order traversal, and we can get the single source shortest path. If the graph had been directed or if the weights had been uh, different, then we would have to use Dijkstra algorithm for single source shortest path, because then our BFS would not work. So moving to the solution on this algorithm, BFS, single source shortest path. How shall we do this? First of all, we are given m edges and n nodes, means we have 0 to 8 nodes. 0 to 8 nodes, and m edges. We are given edges, not the graph. So first of all, we have to create the graph. How can we store our graph? We can have adjacency matrix or adjacency list. Adjacency matrix takes lot of space because you have to make a 2D matrix, and most of the vertices would contain zeros. That means they are not neighbors, so lot of zeros are stored. But in adjacency list, our space is optimized, so adjacency list is preferred to store a graph. So in adjacency list, what we have one parent graph list in which we have lists till all the nodes, means 0 to 9, 0 to 8. We will have 9 lists, and each list will contain neighbors. For 0th index, all the neighbors of 0. For 1 index, all the neighbors, list containing all the neighbors of 1. For 2 index, all list containing all the neighbors of node 2. So this is how we shall store our graph. So let us see, moving to the solution, how shall we create this? So it is a list of list, 2D list, same as adjacency matrix. So we have created that. Now we have n number of nodes, so we need n neighbor lists. So on our parent list, we have added 0 to n, all the lists, added neighbor lists. These are initially empty, and we will now add the neighbors from the edges. Now we have put a loop on edges. We take each edge. It is undirected, means it is bidirectional edge. We can move from 0 to 3 and 3 to 0. So we have to add neighbors for both 0 neighbor 3 and 3 neighbor 0. So we have got the node E0, 0th index. We have taken that neighbor list and added the neighbor E1, and same we do for E1. We have taken the node E1 neighbor list and added neighbor E0. So after this step, we have got our graph in adjacency list form. Now what we have to do, we simply have to do the traversal, breadth first traversal. For that, we need a visited array, that we have visited a node or not. But in this case, we need the distances, single source shortest path. So we have kept a distance array. This array is itself shall work as a visited list, visited or not. Now initially we have filled every whole array with -1, means all the nodes are not reachable. -1 represents not reachable. Now since we are on the source, so distance for source shall be 0 because we are on this source node. Now in breadth first traversal, what we do, we take a queue. So we have created a queue, added our source. Now how, till when will we do this? Till our queue is not empty, we have put a while loop. Now we take the front element from the queue, queue.poll, stored it in f. Now what we want to do, we want to see all its neighbors. So how will we get the neighbors? From our adjacency list, from our adjacency graph, we get the neighbors of F node. For each neighbor, it will be stored in NB. Now we will check if it is visited or not. If it is unvisited, then means our distance should be -1. Only in that case we will add it to the queue because we don't want to go in a loop. So we have checked distance of neighbor is -1. So what we have to do, first of all, we have to mark it visited, or we have to keep the distance. So what will be the distance? Distance will be parent node distance plus 1. So distance of front plus 1. We have stored in the distance of neighbor, and we have added neighbor to the queue. And this shall continue. All the neighbors shall be put to the queue. Unvisited neighbors and visited will be ignored, and we shall get distance for all the neighbors. Now after this while loop is completed, we would have traversed our whole graph and got the distance, single source shortest path from source to all the vertices that are reachable, and the remaining would be -1. So this was what we had to do. So at last we have simply returned the distance array. So this was the simple BFS solution to this question. Remember the things, that it was an undirected graph and unit weight ages. That's why we were able to apply BFS. Otherwise, we would have to use Dijkstra algorithm. Thank you everyone. Thanks for watching the video. I hope you would have got the concepts and some basic idea about graph algorithms. Have a nice day.